The overarching goal of MOSAiC is to provide a better basis for the formulation of individual processes in our climate models.
It's an interesting transition time right now as we move towards this implementation phase and away from the planning phase.
Leg one, as we anticipated, was a very important opportunity to start the field campaign of MOSAiC.
Far away from everything, there's no definition regarding safe work on sea ice. There's nothing, there's no basis. So we had to develop everything from zero.
The ice has been challenging, and the kind of displacement of some of the cities has been a challenge for us to kind of build and rebuild these cities.
Because there was never stable enough ice all around the central lobes in the beginning, and then once we had one part set up, everything shared, and then suddenly nothing made sense anymore.
Ice stations started to break more and more.
From one day to the other, that's a complete installation is moved by 500 meters, surrounded by ridges afterwards.
Seeing that the continuous fracturing during the time, that I think is a new thing.
It's kind of a tangible change in the environment that you're studying that I hadn't experienced in my previous work.
So we set up the camp, study about the measurement, and we have get a lot of good new information, new data.
For the first time, we have been able to study the interactions between the major compartments of the Arctic climate system, between the atmosphere, the sea ice, the snow, the ocean, the ecosystem and the biogeochemistry in so much detail.
The first time measurements that I did in my field of expertise were running the ROV, a remotely operated vehicle, under sea ice in the complete darkness in winter, and to measure the ice properties and the water mass properties right under the ice in the wintertime.
I think some of the snow measurements was really new thing. There were automatic measurements of the snow hardness, for example.
One thing that we did is there is an instrument called the Loki, and it's a camera and net system that is able to take very high resolution, high quality photos of small animals. And so this is the first time that the Loki has ever been deployed in the Central Arctic at this time of year.
We had this big scanning radar on top of the ship, and we've never had a scanning radar looking at clouds in the Central Arctic before.
On top of an ice floe, you make a hole and you do hydrography every day. And I think that is very special.
Aerosol measurements are another huge first. Arctic aerosols are really important for the system. It's something we know is important, but we just haven't been there, especially in the wintertime, to measure Arctic aerosols directly.
What was really special in MOSAiC was that we have so extensive measurements. So we have so many of sensors so that we could have a so good spatial coverage and temporal coverage.
I think that we will build the greatest database of observational data sets all year round with all the different points of view.
The data set that we bring back, even from phase one alone, is so rich it will keep us busy for years and years to come to fully exploit the things that we can learn from that data.
All data will be available for all climate modelers, and I think that will actually be a new foundation for politicians to take decisions from.
The time series that we've created with the sea ice sampling of physical, geochemical, and biological properties over the last 6 to 7 weeks, it's unique. It's never been done before. And so that's going to be an amazing, amazing accomplishment and output for MOSAiC. And there's certainly more than just this, but those are a few of the highlights.